Hi, this presentation is entitled, Holistic Assessment for Chemical Plant Design Capstone Project, which is implemented in Malaysia Japan International Institute of Technology MJIT, UTMKL. Based on the reports from World Economic Forum, Skills Future Singapore, International Engineering Alliance and the University Technology Malaysia, it is becoming increasingly obvious that soon-to-be graduates should be equipped with a bank of soft skills besides just having a degree from higher learning institutions, as all of these are necessary for today and future workplaces. There are a few problems in the chemical plant design project. First, the implementation of the previous model focusing on final examination has led to fragmented learning, and students cannot connect and apply what they have learned in the classroom to a real-world scenario to solve the complex design problem. Second, as for the assessment, the approach used in SMJC 4343, which involves paper-pencil assessment at the end of pre-specified periods, can only encourage memorization and comprehension of course contents, which is frequently associated with failure in assessing deeper forms of learning. Third, the learning in SMJC 4824 heavily depends on the efforts of the academic lecturers or supervisors, which means that learning experiences between different student groups may differ significantly. Fourth, the assessment lacks robustness because the majority of the assessors are academic staffs, who are frequently inclined to prioritize the application of fundamental and textbook knowledge. There is also lacking external stakeholders' involvement, such as industrial players and external lecturers, in the assessment to provide real or authentic feedback to the student. The project provides authentic and open-ended problems to the students, in which the students are required to propose a specified chemical plant design within a provided scope by a designated project team. The team must propose the specific project title based on their preliminary studies, following the real market needs, preliminary economic assessment, potential safety issues and sustainability considerations. Then they can proceed to conduct a detailed design of the plant. The intended course learning outcomes and the teaching and learning activities are constructively aligned with the chemical plant design capstone project's deliverable or assessment. This curriculum design heavily highlights the concept of assessment as learning, while maintaining assessment for learning and assessment of learning. The multi-perspective assessment model is used in the project for the holistic and comprehensive, multi-objective/criteria assessment, which involves self, peers, academic supervisor, industrial supervisor, internal lecturers, external lecturers, and industrial panels. Furthermore, the project implementation is based on cooperative learning theory, in which individual accountability and team processing are required to devise a solution. This would create students to do self-reflection and peer feedback in the team, non-graded formative assessment. Meanwhile, the academic supervisor regularly provides in-time feedback to the project teams, non-graded format, during regular meetings while ensuring the project progress as planned. In addition, industrial supervisors are appointed to meet regularly with several design teams, which are expected to provide authentic feedback, non-graded formative assessment, to ensure the projects are practical. Multiple assessors are appointed for all graded formative and summative assessments to ensure a reliable assessment and the absence of bias in the assessment. For all the reports, 2 to 3 internal lecturers are appointed to evaluate 2 to 3 criteria in the assessment rubrics. Presentations act as formative and summative assessments for the project, in which the evaluation is conducted by multiple internal lecturers, or external lecturers and industries. The supervisors are avoided from the evaluating own team for avoiding bias. Meanwhile, the team report submission is divided into 3 parts, while the individual report consists of 2 parts. The reports are continuous, thus, the previous parts are always required to be resubmitted, and students are always allowed to improvise the reports for second semester evaluation. Since the earlier part of the report are resubmitted and re-evaluated, this provides opportunities to improve students' report and their writing skills. To train holistic future graduates, the assessments in this project have a significant portion on soft skills development. 47.5% of the total graded assessment, which focus on environment awareness, engineering ethics, teamworking, communication skills, and project management and finance. These are essential skills for the students to ensure they can adapt to their future careers as engineers. The self and peers assessment and the academic and industrial supervisors assess the team working element in the project. They have a reliable role in observance attitudes and behavior through regular meetings. This project's communication skills are divided into the presentation and report writing skills. The presentation skill is receiving non-graded formative assessment during students' regular meetings with academic and industrial supervisors, which academic supervisors also conduct rehearsals before students graded presentation assessments. The presentation skills will be improvised through 4 presentation evaluation sessions with internal lecturers, external lecturers and industrial panels. In addition, free riders are always a major concern in project-based learning. Self and peer assessment was done regularly on our students, which included a modified professional behavior instrument and ended questions. The self and peer assessment promotes social skills and positive interdependence in the cooperative learning principle. The reliability of the self and assessment instrument was investigated and concluded that the self-assessment results converged with the peer assessment results after a few self and peer assessment cycles. The coordinator reviews the assessment comments and provide intervention when needed, which provide opportunity team to speak about their issue openly in the team. Besides that, the assessment comments are returned to all the students as feedback, which the coordinator takes the opportunity to share about human behavior, attitude, teamwork and toleration. In order to reflect student contribution to the result, the self and peer results are integrated into the team-based assessment, report, presentation and project management elements in the subjects via auto rating system. The plan, do, study, and act PDSA model is used for the development and continuous quality improvement in the subjects. The PDSA is mainly done by the project coordinator and design project committee formed by the lecturers with professional engineer title and industrial experiences as well as senior staffs. The development of this project model is based on the continuous comment collections from various stakeholders, Engineering Accreditation Council EAC auditors, external examiners, industrial advisory panel, industrial supervisors, industrial evaluators, external lecturers, academic supervisors, alumni and students.
The chemical plant design project has enhanced students' soft skills development. The top table shows the average achievement and professional behavior development or team working from 2018 to 2022. In average, the 4 cohorts have shown improvement in the 3 self and peer assessments within a year. Furthermore, the number of individual students who have improved in their self and peer assessment has also increased from 64% to 83%. This is an excellent indication that the project allowed the students to experience and improve their soft skills. The lower table summarizes the average marks of SMGSE 43-43 and SMGSE 48-24. A drastic change in the achievement of SMGSE 43-43 from 2016 to 2017, in which the subject transformed from a typical lecture class with a final examination in 2016 to project-based learning in 2017. In 2021, the design committee made significant modifications to the evaluation rubrics, which aimed for more holistic and representable rubrics for the students. In addition, the committee trained the assessors to ensure reliable and fair assessments were made. This caused the achievement in 2021-2022 to drop for both subjects. Interestingly, the difference in the average scores between SMGSE 43-43 and SMGSE 48-24 has reduced in 2021-2022. Which proves that the assessment and their rubrics for both subjects are more representatives because they are based on the same project.
The chemical plant design project has enhanced students' soft skills development based on the professional behavior development instrument. After some team deliverables, the achievement is measured via self and peers assessment throughout the 2 semesters. In average, the 4 cohorts have shown improvement in the 3 self and peer assessments. Furthermore, the number of individual students who have improved in their self and peer assessment has also increased from 64% to 83%. This is an excellent indication that the project allowed the students to experience and improve their soft skills. A drastic improvement in the achievement of SMJ 4343 from 2016 to 2017, in which the subject transformed from a typical lecture class with a final examination in 2016 to project-based learning in 2017. Meanwhile, SMJC 4824 has been increasing its score due to the sample reports provided by the seniors. Therefore, the committee made significant modifications to the evaluation rubrics in 2021. Which aimed for more holistic and representable rubrics for the students. In addition, The committee trained the assessors to ensure reliable and fair assessments were made. This caused the achievement in 2021-2022 to drop for both subjects. Interestingly, the difference in the average scores between SMJC 4343 and SMJC 4824 has reduced in 2021-2022, which proves that the assessment and their rubrics for both subjects are more representatives because they are based on the same project. The students' project quality is proven by winning the Best Final Year Design Project 2019 by Institution of Chemical Engineers, while the reliability of the self and peer assessment results are analyzed and published in the International Journal of Engineering Education. The design and evaluation framework of the design project is also copyrighted in 2021. Although not every innovative solution or idea will be a resounding success, and students will fail at some point, or some of their designs will simply not work, the concepts of assessment as learning and assessment for learning adopted in the project's formative assessment serve as a driving force for lifelong learning, encouraging students to continuously learn and think differently than the conventional approach. Chemical engineers who bring forward innovative problem solutions and suggestions that will have a positive impact are valuable assets to a company. Acknowledging the fact that not everyone is born with the ability to be creative and innovative, the skill can be honed through imagination, collaboration, questioning, and information processing, all of which are activities involved in the chemical plant design project. Thank you for watching this video. Do feel free to contact us if you have any questions.